Now, here we go. Find the range of values to satisfy the following. I'm going to bring the 3x and the 4 over the other side. I'm going to get 0 is less than x squared minus 3x minus 10. I'm going to spin that around to get x squared minus 3x minus 10 greater than 0. This is a U-shaped graph, and you would like the U-shaped graph to be bigger than 0. You want the y values that are bigger than 0. You solve where it crosses the axis. Where does it cross the line? Well, you say, well, it's x minus 5 and x plus 2. This implies that its 2 points are x equals 5 and x equals minus 2. That would produce a graph like so. You want your line to be above the axis, like so. That implies these two positions here. For the first part, I got x smaller than minus 2 and x bigger than 5. Did anybody get those two answers? Alright, great. You go to part 2 now, and part 2 is similar. You go, okay, bring the 2x to the left and the 9 to the left. So you're going to get x squared plus 2x minus 15 less than 0. This time you want it to be less than 0. Is that alright? Now, once again, it's a U-shaped function and you want to know where it crosses. So we go for x plus 5 and x minus 3, and x equals 3 and x equals minus 5. So you're minus 5 and you're 3. Okay, it's a U-shaped function, but this time what are we looking for, lads? This time what are we looking for? Above or below? How'd you tell? Above or below? What's that say? Below. You want all the answers between minus 5 and what? 3. Okay. Now, here's the issue now. You ready? You need a set of values. You need a set of values that basically satisfies both equations. How do I know that? Well, if you join the two of these together, see these two? These two equations can be merged into this. You've seen it before at junior cert level, where I do something like this. I say 2 is smaller than x, and then I say x is smaller than 5. And what I would have done in junior cert level is I would have wrote it like this. You can do the same thing with the x squared plus minus 6 on both equations. Do you see that? You sort of merge it into one big one. Now, what will the answer actually look like? Here we go. The answer to the first question was anything smaller than minus 2. Is that alright? What answers from this equation would fit that? Minus 5 has to be smaller than your x values. Okay? So, we're allowed to use the numbers minus 5 because it's smaller than minus 2. We're allowed to use minus 4. We're allowed to use minus 3. Are we allowed to use minus 2? Why not? Because x has to be smaller than minus 2. Stop there for a second, right? You're all good at the moment. So you've just described the set. You've described the set minus 5 less than x less than minus 2. Let's go to the other side. What do all your x values have to be smaller than? All your x values have to be smaller than 3. But they also want them to be bigger than 5. Is that possible? Or are they contradicting each other? You can't be smaller. You have to be bigger than 5 and you can't be smaller than 3. There's nothing you can do there, is there? So what do you think your answer is? Is that what it is in the back of the book? Basically, numbers both sets will have in common. For this, if you're really bad at doing stuff like we just did, here's another way of doing it. Write down numbers for the first answer. Anything bigger than 5, 5, 6, 7, ... Anything smaller than -2, yeah? So you could say, sorry, I got that wrong actually. What's bigger than 5, lads? If I wrote down a bunch of answers, what would be bigger than 5? 6, 7, 8, ... What's smaller than -2? -3, -4, ... Right? Then go to the second answer. What's acceptable in the second answer? Is -4 acceptable? Because -5 has to be smaller than it. You're allowed all these values in the second answer. See all those answers you're allowed in the second answer? Now what's the overlap between both answers? What's the overlap in both answers? Anybody care to tell me? It's just -4 and -3, isn't it? And that's where it comes in. -5 has to be smaller than your x answers, and your x answers have to be smaller than -2. Same deal. Alright. Really quickly. How'd you get the original mass? What does original mean? T equals 0. So replace in 0 for t. And what you get? M equals 30. Grand. How long would it take for the material to decay 10 grams? Okay. If 10 grams are gone, how many grams are remaining? How many grams remain? Huh? 20, exactly. What? Oh, sorry, to decay to 10 grams, my fault. I read it wrong. So the M value will be? Anybody? 10. Okay. I'd like you to tell me something, alright? What happens if I log both sides right now? What happens if I choose a log of my choice and I just log them right now? Good idea or bad idea? What? Alright, it's definitely a bad idea, but can you tell me why it's a bad idea? Am I able to move this power to the outside? Why not? It's only powering the 2. It's not powering the 30. Does everybody get that? What would be a good idea to do next time around instead? Bring 30 to the left. What happens when you bring 30 to the left? 10 over 30, which is? 1/3, exactly. And then we get 2 by -0.001 t. You find these questions aren't so bad now. Pick a log of your choosing. Any log. Log 1 doesn't make sense. I'll use log 10, yeah. What the heck. Now, Matthew, where does the power go? Okay. Okay. Quivine, we want we want the t on its own. So what happens to everything else? So what happens to the -0.01 log 2? What happens to all that? Where does it go? Where on the left? Under. So Quivine, get your calculator out and throw all that in and tell me what you get. Stop that. Alright, go on. Anybody else? Nobody? What? 1,584.96. Alright guys, Last question is, how long will it take to get to the safe level of 1% of its original mass? Just get 1% of 30, which is 0.3, is it? So you're going to do the same question, except m will be 0.3 this time. Same methods. Right, best of luck with the questions.